Hello everyone, welcome. This is a makeup lecture ECE350, the makeup because we canceled 2 lectures during the second week because of the strike, right? And today is one of the makeup. The first one I want to talk is about the midterm exam, and we graded use a grayscope, and it seems it works not so perfect, so some of you will have some lower grade. I will update. I will go over all the I review the papers and make some update. So not most, but a lot of you will have some higher grade. But however, I will say there is still a big problem. About the matrix, how to calculate when you have matrix, when you have the vectors. So I suggest you to review. If you are not so sure, you forget something, you'd better review those part of the linear algebra. Alright, yeah. And okay, so today I will finish the part about the OCF and then go over the homework solutions. Alright, and let me see. Go to the camera, document camera. Yeah. Okay. So this is ECE350. This is a makeup lecture, and we will have 2 topics. One is OCF, one is about the solution of the exercise problems. Alright. For OCF, last time we gave the definition of OCF, and we also gave a method to find the OCF. Let me use an example to explain it. We will transfer. Suppose we have transfer function. We will start from a transfer function. Then we can have OCF, right? Then suppose the G of S equal to 2S plus 4 over S squared plus 3x plus 21. Okay, suppose this is G of S. Then what is OCF? OCF will be x dot equal to AO. I put O here, means OCF. AOX plus BOU and y equal to COX plus DOU, where AO will be a matrix. Actually, it contains 3 part. Total size now is 2 by 2. Right, this is second order system, so this is 2 by 2. 2 by 2 will this part will only need 1 element. If the size is higher, here will be a row of 0. Now it's just 1 0 here. And this part will be unit matrix. Now it is just 1. And here we need 2 element. It's coming from the denominator, of the transfer function. Now the constant term is 21, and the next constant is 3. So we use these 2 numbers. We put these 2 numbers here, 21 here, and then 3. After this, we change the sign of these 2 numbers. So here's a positive 21. Now here's a negative 21. Here's a positive 3. Here will be negative 3. Now if some here's a negative 3, here will be positive 3. Alright, so this is AO. And the BO were coming from the numerator. Still the size is still 2. So this is a vector with 2 elements, column vector with 2 elements. The first number is also the constant, and now is 4. The constant 4, and then 2 is 2. Let me see, 4 and 2, yeah, and 2, yeah, start from constant. This is also start from constant, yeah. And the CO, it is always some zeros followed by 1, and size still 2. And the DO now is 0. Here is a constant. If you hear some, we have some value, that value will be here, right? Now it's plus 0, so this is 0. Okay, now we are done. We know the OCF looks like this, and each matrix are these four matrices. Okay, and the second method, now we give the second method. Second method, to get OCF, we will start from, I still use an example to explain it. We will start from x dot equal to ax plus bu over then y equal to cx plus du. We want transfer to OCF by letting x equal to some qx. Find the x, find the q. Find the q. Find the q. We need several steps. The first one, let O, capital O, equal to C, CA squared, CA n minus 1. The size is n by n. Then we check the determinant of O. If it is 0, then no OCF. Is not 0, we have OCF. We have OCF. So the first step, you do a check. If it's 0, you do not need the rest of the work. And then we calculate. Okay, second one. Calculate determinant of. Okay, here's a not method. This is a here's not an example. It's a method. Okay, method. The whole method. Calculate this one is Si minus A, and the result, of course, it depends, but we can write it in this way. It is a s to the n plus some a1 s to the n minus 1 plus a2 s to the n minus 2 plus until a n minus 1 s plus a n. Right? We can always write in this way. These coefficients a1, a2, they were depending on what is a, but there will be some numbers. Right? I have this one. Now I let m equal to, this is the matrix. Okay, here along this line they are ones, and below this one, this triangular order element here, they are zeros. And here, this part, we give the first row firstly. First row is coming from the coefficient of these. Actually, this is a characteristic polynomial, right? Polynomial. Yeah, polynomial, right? Characteristic polynomial. So we use the first row. First row use these coefficients. So this is 1. 1 is the coefficient of s to the n. And here this is a1 until it's a to the n minus 1. A to the n minus 1. Totally n by n, right? N by n. So the first row. Second row, we shift to the first row. We shift the first row by 1 to the left side. So y is here, ay is here, like this. Alright, the next will be 1 and a1 here, and so on. Alright, let m equal to this one. Now we just let q, let another the q, right? We want to find the q. Just let x equal to qx. Oh, sorry, I missed a bar here. Qx bar. X equal to qx bar. Right. Okay. So now what is q? Q is m. This is m times this o, and take an inverse. That's it. That's it. Then x equal to qx bar will make the original system. I say this, I gave a number. I say this is 1. The equation set 1. 1 or make 1 turn to be OCF. That means AO equal to Q inverse AQ, BO equal to Q inverse B, and CO equal to CQ, and DO, it is just D. DO is just D. Alright. Okay, now we check the example. G of S equal to S plus 6 over S squared. Okay, I put the negative. We try some negative one. Minus 2S plus 10. Okay. No. This is for transfer function. We know how to find the OCF from transfer function. Now we will start from a matrix. Okay. I have x dot equal to some A. A is, I give anything 1, 2, 3, 4 times x plus B 2, 1 B times U, and y equal to C, like a negative 1, 1, and x plus D. Suppose no D. Alright. D is give D is also fine. Plus U. The D is 1. D is 1. Okay. Now we work. We follow the step here. Okay. We find this O firstly. Check the determinant to determine do we have OCF. And then if we have OCF, then we calculate these determinant matrix, get this polynomial, then we can find what it is M. Then we can have Q follow this. Alright. So the first one, we check the we need O, determinant of O. So find O firstly. O is C times CA. Now its size is 2, so we only need 2 rows. C is just 1, negative 1, and 1. This is C. And C times A. C times A. C times A equal to negative 1, 1 times A. A is 4, 3, 2, 1. So how to calculate? Yeah, I saw you guys, some of you do not know how to find this one. This result, it will be a matrix. This is matrix times matrix. So this is a matrix. And this size, this matrix of this size, it will be like this one is a, this is a 1 times 2. 1 row, 2 column. This is row, number of rows, and this is the number of columns. And this one is 2 by 2. 2 rows, 2 columns. And after you times these two kind of matrix, The result will be 1 by 2. So how to get this 1 by 2? You will keep this one and keep this one. It is 1 by 2. This 2 and this 2, you just remove these 2, so the result will be 1 by 2. Right? Similar, any matrix. Let's say this is like n times m, n times another is m times p. You will have a matrix with n times p. This is n row m column, m row p column. The result is n row p column, n row p column, right? In generally. And then the element, you determine the size, right? Then you need to check the element. The element, this is a -1 and 1. Okay, you choose one row times one column. So this is a first row times the first column. First row times first column. So here location will be in the first row in the first column. The first and first. Right? First row, first column. So this is first row, first column. Okay, so -1 times 4, I have -4, and 1 times 3, I get +3. Totally is -4, +3, so this is -1. Okay, -1. And then we use the still first row, second column. So here is the first row, second column is here. So it's -1, 1, and 1 and 2. You times element per element, and 1 times 2, right? -1 and 1 and 1 and 2. You have -1 and +2. Totally is 1. -1 +2, you get 1. So say A. Oh, unfortunately, this is equal to 0. Say A. Now I get -1 and 1. Let me see. -1 and 3, I get -1. -1 and 2, I get 1. Oh, this determinant is 0. No OCF. Right? Determinant is times in this way. -1 times 1, you get -1, and minus -1 times 1 minus another -1, you get 0. Okay, not good example. We try another one. Example 2. X dot equal to, I still use this 4132 times x plus 21u, but I use different c. C is I put 2 and -1. Is this good? Hopefully. If it is not good, I will change this value here. Okay. Then the first step, we find what is the matrix O. It is called the observable matrix, observability matrix. It is C and CA. C is 2 and -1, and CA equal to C is 2 and -1, and A is 4132. This gives us, okay, this is still 1 by 2, right? This is 1 by 2, this is 2 by 2, the result is 1 by 2. So 1 row, 2 column, right? The first element, actually here is the first row, first column, right? This is first, this is also first. This is first and first, so here is the first, here is the first. So this row and this column, I get this element. It's 2, 4, 8. 8 minus 3, I get 5. Then this is the first row and second column. The first row and second column. Yeah. So it's 2 and 1, I get 2. -1 and 2, I get 0. Okay, this time is good. I get 5 and 0. and the determinant of O is 2 times 0 minus -1 times 5, right? You times in this way. I get 5 do not equal to 0. Okay, good. We have OCF. Yeah, we can have OCF. Now I will try to find it. I need to find the similarity transform. Before that, we need to calculate determinant of Si minus A. So this is determinant of S and I. I is 1001 minus A is 4132. Okay, determinant of, so S times this one. So an element times a matrix. This is not matrix times matrix. This is a number times matrix. Then you use this number times every element inside the matrix. So we will have S times 1, I get S. S times 0, I get 0. S times 0, I get 0. S times 1, I get S. And minus 4132. Okay, the same like some constant K times A, B, C, D, E, F, G, H, I. It will be K times A, K times B, K times C, K times D, K times E, K times F, K times G, K times H, K times I. You times all the element of this matrix. Okay. The number times matrix. This is number. This is the matrix. Matrix of vectors. Okay, then you do subtract. It's just element by element. This is just element by element. So S minus 4, 0 minus 1, 0 minus 3, S minus 2. Right. Okay, then now we can calculate the determinant. You need to calculate, in this way. In this way. So S minus 4 times S minus 2. And this way is -3 times -1. And here's a subtract, not summation. Here's a subtract. Then the result will be, okay, I times them out. This is a S squared minus 6S plus A. And here's a minus 3. So totally is S squared minus 6 plus 6S plus 5. Okay, the result is this one. Okay. If you want, you can write it as S minus 1 times S minus 5. This is not necessary. Okay, not necessary. So we need this one. Okay, now we can have M. M will be, we know these two elements should be 1, and here's a 0. Right, only need two rows, 2 columns. And what is this element? You're coming from here. The first one is a coefficient 1. Actually, this is 1. And then -6. So here's the -6. Alright. So this one, go to this one, and this one. Okay, 3 bars, -6 is here. This is M. Okay, now the third step, we can define what is that Q. Q equal to is an inverse of M times the formula M times, I put it here, right? M times O inverse. This is Q. So now let Q equal to M times O inverse. Okay, so this is a inverse of M. M is -6,110 times O. O is here. Is 2, -1, 5, and 0. times O, then take the inverse. Now we need to find these two matrix times together firstly, right? So it is the inverse of this matrix. This matrix, okay, you check the size firstly. This one, it is a 2 by 2. This is also 2 by 2. So the result is also 2 by 2. Remember, we used we determine the size. We determine the size. We need this element and this element give the size of the result. Right? Here's a 2. Here's 2. Here's a 2. Here's 2. And of course, we need these two numbers are same. If they are different, you cannot times them together. The size doesn't match. If you calculate in MakeupLect, you put the two matrix, you want to multiply them together, times them together. If their size doesn't match, MakeupLect will tell you the size doesn't match. You know, yeah. Okay. So here is 2 by 2. Now we calculate each element. So this one, this is the first row and first column, right? This element. So you use the first row. This is first row, and this is the first column, right? And this is second, right? First and second. Here's the first, and here's the second. 2 row. Here's 2 column. We choose the first row, first column, first row, first column. Go to here, first row and first column is here. Alright. Okay. Now, first row -6 and 2. I get -12. This is 5. -12 plus 5. I get -7. -7. Alright. Then the second. This one. This is the first row, second column. So the first row and second column. You see, first row, second column. Okay, I times them together. -6 and the -1, I get 6, and 1 and 0, I get 0. So 6 plus 0, it is 6. That's 6. All right. Then this element. This is the second row and the first column. So here we choose second row and first column. So I have 1 times 2 plus 0 times 5. 1 times 2 is 2. 0 times 5 is 0. 2 minus 0. I got 2. Right. And then 1, 0 times -1, 0. This is second row and second column here, right? Second row, second column. So 1, 0 times -1, 0, I get -1. Alright, so this is the M times O. I get these. Then the inverse matrix. Inverse matrix, it contains 2 parts. The first part is a coefficient, constant coefficient, number coefficient, right? It will be 1 over the determinant, and times how to say, we change this matrix. We need to change. So we need to flip these 2 elements. This is -1 and -7, and 6 and 2 we keep them but change the sign. Alright, okay, so the determinant, what is determinant? Same way we calculate determinant in this part, right? Yeah, here we need a determinant of O. Now we calculate the determinant of this matrix. So it is 1 over -7 times -1 and minus 2 times 6. Okay, here's a -1, -6, -2, -7. This will give us, okay, this is a 7 minus 12. I get a 5. 1 over -5. Okay. Actually, here's a -2 times -6, but the negative cancel. So I just put 2, 6. and inside is -1, -6, -2, -7. Then you times 1 over 5, 1 over -5 inside to all the element. This is the number times matrix. You just times this number on each element, element by element. So this is just 1 by 5. I write it this way: 1 by 5. This is 6 by 5. 2 over 5 and 7 over 5. All right, I got this cube. I got this cube. And actually, at the same time, we know this part will be Q inverse. Inverse equal to -7, 6, 2, and -1. You should know what is Q inverse, right? Actually, Q times Q inverse equal to unit matrix. It is also equal to Q inverse times Q. You change the order, you will get same thing. But this is only for some matrix times inverse. If they are two matrices without any relation, you cannot change in order. Change order, you will have different answer. Yeah, here change order, but have same answer. This is only for Q and Q inverse. You can change in order. Okay, then let x equal to q x bar, and in the original system, I say this is example 2. I say 2 in the equations 2. We can have x bar derivative equal to q inverse aq times x bar plus q inverse b u. Here's y equal to c q x bar plus d u, where q inverse aq, actually this is just AO, it will equal to now some calculation, right? We have q inverse -7, 6, 2, -1. This is q inverse times A is 4, 3, 2, 1, and then Q is this 1 over 5, 6 over 5, 2 over 5, and 7 over 5. This is AO. We can calculate. Now you have three matrices. You need time them 2 by 2. So first two, you times them together. This is 2 by 2, 2 by 2, right? 2 by 2. This is 2 by 2. So the result will be still 2 by 2. Remember, you use the first index and the second index, and these two they cancelled. After you cancel these two, you have 2 by 2, right? You have 2 by 2. Then the first row times the first column. Here's the first row, first column. You get this element. So it's -7 times 4 plus 3 times 6. Oh, I need to calculate it. Yeah, I can just put it here. I copy this one, 1, 5, 6, 5, 2, 5, 7, 5. Okay, here I do the calculation. This element is this one times this one is 28, -28. Then 3, 6 is plus 18, so I have -10. So this is -10, -10. And then first row, second column. Here, first row, second column. First row, second column. So I have -7 times 1 plus 6 times 2. So this is a 5, positive 5. And then this element, this is the second row, first column. So second row, first column, I have 8, minus 3, right? 2, 4, 8, 1, 3, 1, 3. So 5 and 5. The last one is the second row, second column, right? Here is the second row, second column. The second row, second column. I get a 2 minus 2, it is 0. Alright, the next. Now I need to times these two together. The result is still 2 by 2. 2, 2, here's a 2 by 2. So I need a 2 by 2 matrix. Then first element here, this is first row, first column. First row, first column, right? First row, first column. So you first row, first column. You times these two together, and put it here. So these times I get a negative 2, and this is positive 2, so it's 0, right? Negative and positive 2s. And then this is a negative 12, and this is a 7. Negative 12, right? Negative 12 plus 7. Again, negative 5. Again, negative 5. Negative 5. And then this element is 5 zeros times this second row times the first column, right? Second row, first column. So second row, first column. Second row, I get 1 times this at 1, and this times is just 0. Okay, so this is just 1. And then last, this second row times the second column is here, right? Second row, second column is here. So 5 times this, I get 6. 6 minus this is just 6. 5, 6, I get 6. This is just 6. Alright. Okay. So we have, this is a AO. We have AO. Then we can have BO, which is a Q inverse times B. And the Q inverse is negative 7, 6, 2, negative 1, and the B is 2, 1, 2, 1, 2 and 1. Okay, I times them together. Now the size. Firstly, you need to determine the size of the result. So the first one is 2 row and 2 column. And second one is 2 row but 1 column. The result will be 2 row, 1 column. So here's a 2 row, 1 column. Then the first row, this is first row, first column. So you use first row, first column. That is a first row, I have negative 14, and the first column 2 and 7, so 14, 1 and 6. I get a negative 8. Right. And second, this element, second row, first column. So second row, first column. I times them element by element, I get 4. Element by element, get negative 1. 4 minus 1, this is 3. So this is BO. And the CO, it will be B times, not B, it will be C times Q. C is, check the original, C is here, 2, negative 1. 2, negative 1. And 2, Q is, where's the Q? Q is this one. Q is here, right? Q is here. Q is here. Let me copy. Q is 1 over 5, 6 over 5, 2 over 5, and 7 over 5. Alright. Same thing. We check the size firstly. This is 1 by 2, 1 row, 2 column. This is a 2 row, 2 column. Right? 2 row, 2 column. Then the result will be 1 row, 2 column. So it is 1 row, 2 column. 1 row, 2 column. Right? 1 row, 2 column. Okay, this element This is first row, first column. So I use first row, first column. I times them together. I get 2 over 5 minus 2 over 5. You see? 2 over 5 minus 1 times 2 over 5. So I get 0. This is 0. Then this element, the first row, second column. So this is first row times here, second column. Okay. I have 2 times 6 over 5. I have 12 over 5. And minus 7 over 5. Right? Minus 7 over 5. I get, okay, this is 5 over 5 is 1. It is 1. Yeah, as we wished, right? We know the OCF, C should be 0 and 1. Yeah. And the DO, it is just D. What is our D? Our D here is 1, so it is 1. Okay, we're done. We have OCF is x bar, take derivative, equal to AO. I just get AO this is AO is here is 0, 1, negative 5, 6. This is x bar, and plus BO is here, negative 8, 3 times U, and Y equal to CO 0 and 1 x bar, and plus DO, it is 1 times U. So we have OCR. Alright, so the whole process should be like this. In the homework assignment, we are asking for some, like, you just need to find O's. Alright, yeah, okay, let's go to the homework. Homework solutions. Now we know the method, right? And last time I gave the way to find the CCF. Should be similar. They are similar. Now let's check the homework. I have the solution here. Let's go over. Wait, homework. Okay, this is one. This is one. Homeworks. So this one we need to find the. Okay. We need to check. Yeah, this is a. You write S. Actually, C. I prefer use C. C, the controllable matrix or controllability matrix. Controllable matrix. Because you check the determinant of C equal to 0, then no CCF. Determinant of C do not equal to 0, we have CCF. Right? We need these two. So here I would prefer write it as C. So this is CF. P equal to CF. Right? CF. And what is F? You need to check this one. This notation means determinant, right? Determinant of a matrix equal to any matrix. Okay, I say this is a sum. Any matrix K equal to, writing this way, same notation, same notation. So this is 2 bar means determinant. Determinant of Si minus A. Now A is according to this, here do not have the original problem, but you look at here, you should know this should be 0, 2, 0, 1, 2, 0, negative 1, 0, 1. This should be A. And Si minus A, this one. Okay, this is a third order, so if you want, you can use MakeupLect to find this polynomial. Can we? Yeah, I think we can find it. Use MakeupLect to find this. But in our quiz or exam, I only ask for second orders. But now, after the calculate, You get this one. You get this one. Then the M will be, here's a 1, -3, 2. 1, -3, 2. Not 2. Oh, they have a term S plus 0 times S. So the third term coefficient 0. So 1, -3, 0. 1, -3, 0. 1, -3, 0. And shifted this line, you get 1 and -3. And shift one more, you get 1. This is M. This is M. The P is M times C times M. C times M. This is just multiplication. This one times this one. You use you determine the size. They will be 3 by 3. Right? This is 3 by 3. This is also 3 by 3. You use the first matrix, the first index, and the second matrix, second index. You get this 3 times 3. I put the 3 bar here, 3 bar here. This 2 bar 3 is here. This 3 bar 3 is here. You get this 3 by 3. Then element by element. This is this is the first row, first column. You choose first row, first column. You get this one. All right. Okay, so this question just ask you what is P. So by x equal to px bar, we can have CCF. We can have CCF. We can have CCF. But the problem just asks you P. You do not need to calculate this part. All right. And then all the rest of the problems in the first will be similar. Yeah, they use S. Should be the C. C. Okay. Yeah, same way. Just the size, all of them, order 3. You can try, if you want to do, you can try to do this. This is 2 by 2, right? Try to do this, 2 by 2. Yeah, try this. You do by yourself, then compare with the result. And also you can follow it here like this is Y. Why you have this? Why you have this? 0, 1 should be, this should be B. And this is what? This is what? Now you need to calculate by yourself, right? And you get this one, Y. You need to calculate, find the details. The solution is do not give you all the details, but you can try to find these. All right. This is the first problem. Second problem, similar, but now is this is use V. This is for OCF. Find the Q. Find the Q for the OCF. Right? For the OCF. Yeah, find the Q. This should be it's a V. I prefer use O. Use O. This is the controllable. Not controllable. This is the observable matrix. Right? Observable matrix. So now is the size 3. So say A and say A squared. You have this matrix. Then follow the formula: M times V inverse. Hey, yeah. Here the it's the same problem from previous 10-13. So same app. Right, we have this M in here, right? We have M here. We calculate the determinant of. Okay. We have these. We have these determinant. Then we have M. Now I just use this M. 0, -3, right? 0, -3, yeah. 0, -3, yeah. This is same app, right? Same app. Then you do the calculate. This is a Q. Yeah, similar thing. You find the M. You find that observable matrix. Then you get Q. Okay, so all these you get Q. All the last one is a size 2 by 2. So you can try this. And then 15. Did I give you 15? No. 15 find eigenvalue, eigenvectors. We do not need that part. So okay, here we need to find the CCF and OCF by the transfer function. Actually, the answer I think is, let me see. We try to work in our way. This is a s squared minus 1 over s to the 4th minus 2s to the square. S squared. Okay, so the A should be, this is a, okay, this is B. This is a BC, right? No problem. This is a CC, right? It's coming from the numerator. So the coefficient is -1, then 0. This is s squared plus 0 times s plus -1. So the first element is -1, then 0, then 1. They need a 4, a size 4. So 0 times s cubed. So another 1. So -1, 0, 1, 0, right? -1, 0, 1, 0. So this gives this one. And here, you see, two part. This is a unit matrix. This is 0. This is AC. Right? This is AC. This is AC. This is AC. And the last row, we're coming from here. This one, this S4 minus 2S squared equal to S4 plus 0 times S cubed minus 2 times S squared and plus 0 times S plus 0. Then the coefficient here will be 0, 0, negative 2, 0. 0, 0, negative 2, 0. But we need to change all the signs. 0 change sign, still 0. But -2, you change the sign, you get +2. Okay, so this is AC, right? So we can work like this way. And here, they write in this way. Okay, this is another way to find the CCF. This is algebraically. But I already discussed the method to use a signal flow graph. So you can just use my method, is fine. This method is also okay. If you want to use, you can just study this example very carefully, then you can understand how it works. Okay, that's your choice. So this is a CCF. And OCF, after you get CCF, you just transpose. Yeah, just transpose. So this one transpose, you get this one, right? Here's 0, 0, 1, now is a no, therefore this one, and the y equal to 0, 0. They need one more, 0, 0, 0, 1. Yeah, here's a need one more 0. We did 1, 2, 3, 4. So here's 1, 2, 3, 4. Yeah, one more. Size is 4 rows. 4 rows times 1 column, right? 4 rows. So here's, and now this one is 4. Yeah, this is good. Okay. And here should be this one. This should be. I think this is not the transpose. I do the transpose. Oh, no, not this. Okay, so this should be this one. 0, 0, 0, right? This one. And the unit matrix will be here. 1, 0, 0, 0, 1, 0, 0, 0, 1. And here will be this row now to be this column 0, 0, 2, 0. Yeah, answer should look like this. Not this. And this y will be this one times x plus d, no d. Do we have d? No d. Yeah, just plus x. And this u, this one should be just this one is negative 1 0 1 0. Okay, so this is the CCF. This is CCF. This is OCF. This is CCF. Okay, so this one they have some mistake here. And similar for second one. So the s 2s plus 1 over s squared plus 4s plus 1. So numerator is 2s plus 1. So we will have, okay, yeah. Let me copy it here. Transfer function is 2s plus 1 over s squared plus 4s plus 4. Right? It is this one. It is this one. And then this is CCF. Here's a 0 1, and here's a 1 and a 2, 1 and a 2, right? No problem. And here will be 0 and 1 is okay. Then 4 and 4, 4 and 4 change sign, -4, -4. Okay, so this is good. Yeah. And then the OCF. Now OCF they write it this way. Okay, we can see OCF should be, I just write x dot equal to, just transpose, right? It's 0 1 and -4 -4 x plus 1 and 2 u, and y equal to 0 1 x no d. Should be like this. This is OCF. And here we can see this one is they use -4 and 1, and here's the 2, and this is x2 is 4 and 0, and here's 1. What it is? And y equal to what? Y is x1, so it's 1 0. Oh, they use a different order, right? Here's y equal to x2. They use x1 for x2. Okay, this is not not OCF, not OCF. Some problem. You can just transpose this one. You get this one. Yeah. Okay, so this is this problem, and what is the next problem I gave to you? Yeah, check the next will be this. Well, we don't need this. We check the controllable and not controllable, right? You just check the determinant of that C equal to 0 or not. Equal to 0, not controllable, right? Equal to 0, not controllable. Not equal to 0, then controllable. And C is b a times b a squared times b until you have a square matrix by n matrix. Yeah, this is nothing special. You just calculate, and you can try the find the size with 2 by 2. You can try 3 by 3. You can read it and calculate it too complex. This is problem 18. The next is what? This one is 19. This is not controllable. Oh, you check the controllable and observable. Okay, so this solution is just work. Use MakeupLect. But we can just use this one. Just use this one. Alright. Oh, did I give you this problem? This is 19. This is a problem 19. Oh, we do not need this. I think this is I believe this is the same as 18, but he is working by MakeupLect. Okay. Then the next problem. Not this. It's for 48, 49. Yeah, 49. 49 is a system. We have some parameters. What is A? Yeah, sorry, I can figure out what is A. But the thing is, like, you want to check it is either. Okay, so it is complete, observable, and controllable. This matrix, they contain some parameters. We want both are controllables, and then we need the determinant do not equal to 0. So we need to remove. When this is 0, we can find this equal to 0 or this equal to 0. When this equal to 0, we get this equal to when D1 is not 0, or when D3 is not 0, I think this so D2 cannot be, so complete observable. This is yeah, just calculate. You calculate, make them not equal to 0, determinant not equal to both, determinant not equal to 0. Then you have some condition on the B1 and the B2. Okay, let me check. This is B1, B2, minus B2 and B1, and minus B2 squared. This is the determinant. This is determinant. It equal to 0. Is the whole thing equal to 0, or just the yeah? This one will give us B1 minus B. Too small. 1, 2. Oh, this is to cancel. Okay, this is just negative B2 square equal to 0. So this one, it is just this one, B2 equal to 0. So B2 equal to 0, do not equal to 0. This is condition for controllable. And this one I have D1. Okay, this is a D1 square plus D1 D2, right, times this 2, and then minus the times this 2, minus D D2 square. D2, right? D2 square. This is a D1. Okay, so this one equal to 0. Whether or not we want it both controllable and observable. So first of all, we want D1 is not 0. D1 is not 0. This one is what? Okay, suppose we already have this is a B1. This one is a B2. This is D2. Oh, it's different. This is B. This is D. So this is a D1 square plus D1 D2 minus D2 square. This one do not equal to 0. You cannot let this equal to 0. In which case this is not equal to 0. Writing this way: D1 square plus 2 times D1 times 2 over D2 over D2, and plus D2 square over 4, and minus D2 square over 4. Right? They cancel, and that means they are same, and minus D2 square, so equal to D2 square. So this is a D1 plus D2 over 2 square equal to D2 square. So this gives us what D1 plus D2 over 2 equal to D2, or D1 plus D2 over 2 equal to negative D2, right? And these gave us D1 equal to half of D2. This gave us D1 equal to negative half D2. Okay, so this condition will be D1 do not equal to positive or negative 1/2 D2. This is condition. So this condition gives us observable. So this condition, it is controllable. This condition is observable. Yeah, here this is not good. This is not good. Okay, this is the last problem. All right. So this means, you know, when you have some parameters, you can choose different parameter. You will try your parameter. You select the parameter so that the system either controllable and observable, both, satisfy both. So you need to choose B1. You cannot choose a 0 as B1. Choose any non-zero B1 is good. And also here D1 and the D2, you will choose any value, just do not let them like one D1 is half of another D2. If you, for example, you use D2 is 2, then D1 cannot be positive and negative 1. D2 is 6, then D1 cannot be positive or negative 3. You can choose any other values. All right. Yeah. Okay, that's all for this lecture. A little bit long. 66. I have 16 minutes more. Sorry for that. Just I pay some time on the matrix, right? We have to calculate carefully. So matrix calculation actually is not difficult, but it is more things than the calculation of numbers. So you have to be carefully, step by step. All right. Okay. Bye bye. See you Monday.